My name is Klara Bulc Rozman. I come from the Faculty of Medicine, University of Ljubljana. And the title is Neurotoxicity of cumyl-PINACA synthetic cannabinoid, involvement of multiple cannabinoid receptors. What are synthetic cannabinoids? So these are compounds that bind to cannabinoid receptor. One of them is also cannabinoid receptor 1, CB1, which is also the target of tetrahydrocannabinol, THC, the psychoactive compound from cannabis sativa. The development of synthetic cannabinoids started in 1980s with development of drugs to alleviate pain. But as they found out that it's actually the CB1 that is implicated in this action, the development ceased. Nevertheless, the discovery of CB1 sparked further research, resulting in over 300 molecules with different affinities to CB1 and CB2. As potent agonists of CB1, synthetic cannabinoids became interesting for drug dealers and their customers, and can be purchased as potpourris and incense, where they are sprayed onto dried herbs. As a small change in the molecule can result in a different effect, there are occurrences of different intoxinations among the users. One of such interesting intoxination was the zombie outbreak in 2016 in New York, where intoxicated persons were standing or sitting on the pavement. They stared blank. They were lethargic. They had a very like zombie movement, and also were groaning from time to time. Lately in Slovenia, the synthetic cannabinoids are sprayed on the low THC cannabis, and this form of synthetic cannabinoids in traffic are found a few times yearly in Slovenia only. How did we come across the synthetic cannabinoids? There was a package of food supplements that came to the international airport Ljubljana, and upon inspection by customs inspectors, they found out that one of the bottles is compromised. They got this substance on their hands. They were not wearing gloves. And in about half an hour, they developed drowsiness, blurred vision, tachycardia. They were escorted to to the hospital and hospitalized, of course. And their symptoms resolved in 2 days. So later it was found that this food supplement is actually cumyl-PINACA, or Stargate 24. This drug was patented in 2014 along with a bunch of other substances, and its purpose was to alleviate pain, nausea, and to stimulate appetite, good mood, and euphoria. It is a very strong binder of CB1 with 0.15 half maximal effective concentration, which is about 100 times lower than that of THC. As the mechanisms of cumyl-PINACA are rather unknown, we decided to check its effect on primary cultures of right cortical neurons and right cortical astrocytes. As you can see, Stargate and partially also THC induce disintegration of cells, and also some condensed nuclei, while in astrocytes we mostly observed the reduction in cell number and spherical astrocytes. The effect of Stargate was also already present at 10 nanomolar concentrations, while THC was effective at a bit higher concentrations, and the astrocytic culture was more resilient. Next, we did flow cytometry to see whether which is the method in the death that occurs. And in astrocytes, there was some occurrence of apoptosis, but mostly necroptosis developed due to the insult, while in neurons, there was mostly apoptosis with some necroptosis by THC. These results correspond nicely with the caspase activation, which is activated in astrocytes in the first few hours, but then we see the decline of caspase 8 activation in the Stargate as well as in THC, and also an increase in lactate dehydrogenase in the media, which signals the compromised cell membranes. All these data correspond to necroptosis in astrocytes, while in neurons we have a gradual increase in the activity of caspases, a little bit less for THC, and also no or very little increase in LDH for Stargate, and a higher increase for THC. Since we were interested which are the targets of the Stargate, we decided to check the cannabinoid receptors. We checked the expression of CB1 and CB2, and also for expression of some other non-cannabinoid receptors, as PPR gamma, peroxisome proliferator activator receptor gamma, vanillate receptor TRPV, and G-protein receptor GPR55. All the results are normalized to astrocytic culture, so we can nicely see the increase in the higher expression of CB1 and vanillate receptor in neurons, while PPR gamma and GPR55 are highly have a higher expression in astrocytes. With the use of antagonists, we found out that in astrocytes, the viability is the reduction of viability by Stargate is antagonized by the CB1 receptor. Just for info, first is the CB1, then it's the PPR gamma, TRPV1, GPR55, all the way. While the CB1 antagonist was also effective in ATP, in mitochondrial potential, and also in caspase activation prevention. The effects of other inhibitors were partial. The PPR gamma did increase the ATP and the mitochondrial potential, and also decrease the caspase activation, but the effect on viability was not so prominent. Next, the neurons. We also see here that the CB1 is the main pathway, but also PPR gamma and TRPV antagonists have some effects on the better state of neurons. So in conclusion, we found out that Stargate induces necroptosis through the action of CB1, either cytoplasmic or mitochondrial, and also PPR gamma is activation of PPR gamma is also present, while in neurons the effect is mediated by CB1, TRPV1, and also PPR gamma, leading to apoptosis. Why we would like to elucidate all these targets? Because when we come across an intoxication, we would like to elucidate the mechanism to find appropriate targets and appropriate therapeutics to stop the sorry. So we don't get any fatalities due to intoxications. I would like also to thank to my co-workers. All this work was orchestrated by Damjana Mojca-Juric from the medical faculty and also by Miran Borvar from the University Medical Center Ljubljana. And flow cytometry was by Metoda Lipnik-Stangl and also my supervisor, Dusan Shuput. Well, I would like to thank all of them for their scientific input and support, and also thank you to the audience.